leave by like 6:40 because I have somewhere to be.
Okay, sounds good. Let's get started then.
I'm trying to pull up my thing.
Which one?
Because I tried working through the problems, and I got all the wrong answers.
Oh, no. Okay, let me get my calculator. Okay.
Okay.
Okay, for the desktop thingy online, that shindig, what button are we supposed to press again?
The VMware one?
Like, because I'm, like, the desktop, I don't know where to go from there, so I was trying to mess around with it, and...
It says like IM or something, like interstatistics, or it's a circle. It's a blue circle.
Oh, okay. See, it's so confusing that it's a desktop. We should just have, like, the little link on our own.
Yeah.
So it just throws me off. Alright, I remember that. Yeah, I was going through it, and I was like, wow, there's a lot of problems. There's way more than there usually is, it seems like.
Yeah.
Okay, so... do you understand how they get the answers, though?
Some of them. Do you?
Yeah, I think the only ones that I was having a problem with... Well, when I looked at it... let's see. For the most part, I understand, but it's little details that I don't understand, if that makes sense.
Yeah, it does. See, I thought that I completely understood until I looked at some of the answers.
Okay. Well, because, like, let me do this again. Because, see, like, okay, like the first one for 6, do you get how they got the 1.6?
Yeah. The one.
Like,
What part?
just the z-score.
Oh, yeah, okay.
And see, the part I don't understand, because after I went over this, I'm looking at the answer page right now for A, but the 0.05, that's the one thing that I was, like, super confused on.
Okay, that one I understood, I think. Wait, how did I get that? Okay, so you get the z-score, now I'm just going over this in my head, by doing the number minus the mean
Yeah.
divided by the standard deviation, right?
Yeah.
Okay. So that gives us a z-score. And then, should I go from the z-score? Oh, the probability applet.
Oh, okay, that makes sense. We enter the z-score. Okay.
Now I'm going to
Let me see.
pull it up and check it out.
Yeah, mine's not doing anything.
Nope, that wasn't right.
Okay.
Oh, wait, was it? Let me see. After you enter that in for the z-score, all the things on the right of it, before
How do you highlight? Oh. Oh, I see. Okay,
click
hold
on it.
on. 1.6. what is it again? 1.6136.
Uh,
And see, my answer's not the same because you can like move it inward. So where do you put the red lines?
right, so you don't move it. The red line, you type in the z-score in the box, and you don't touch the red line.
Oh, okay. Let's
You
redo
just
this.
click so that the only part that's blue is right after the red line, so only a little bit, and then up in the area box, it will give you the percentage.
And see, mine's not matching up. Mine says 0.1065. What does yours say?
In the area box? So what has 0.05?
Yeah, I put, okay, so in the z-score I put the 1.6136, and it automatically changes it to 1.614, and the area says 0.1065.
Oh.
So mine's not even the same. So that's where I'm getting super confused.
Okay. So that's what mine looks like.
That is so weird. Okay. Wow, I wonder why we're getting different things. Because mine is the exact same. My red lines are the same. My z-scores are the same.
So is your highlighting the same?
No, just kidding. Hold on. Okay, we got it. I didn't know you could change it on the other side. Okay. I got it. We're good. That makes sense. Thank you.
You're welcome. I could show
Okay.
pictures, which makes it a little bit easier.
Okay, so we got that, right? We know how to figure that out.
Yes.
Okay. So you ready for B?
Yes.
Okay. If a student's score is the 10th percentile, what would their corresponding z-score be? So
Show my work. Because I was able to do all of this, but I don't remember how. Oh, that's with the applet. Do you know how to do that one?
So I'm rusty.
He was just having us do it.
Yeah.
Put 0.1, and then the z-score will bump the -1.
Okay. Okay, yeah, I got that part. Okay. Okay, so like if it were to say if a student scores in the 20th percentile, it'd be 0.2.
Yep.
Okay, then yes, we got this. Okay, so what is the quantitative GRE score for a student who scores in the 10th percentile? And that's...
So that one we use that formula for.
What?
It's a formula.
Isn't it just the score minus the mean?
It's the z-score equals x minus the mean. No, yeah, x minus the mean over standard deviation.
Yeah. So...
And you have to solve for x.
What's the mean?
They closed earlier. 1 50.8.
Oh, that didn't work. Hold on. So does he want us to round the entire time?
I think everything's supposed to be 3. Is it? Yeah, 3 decimal points.
Okay. Okay. So do you get how to do that one? Cause
Yeah.
okay. Making sure. So the answer is rounds to 140.
Mhm.
Okay. You want to do number 7?
Sure. I just got a really wrong answer. Okay. I know how to do that, but for some reason, having to do simple algebra is just really confusing me. Because I got the right answer when I did it earlier. But, so, if we have to solve equations, you can just help with that. Okay. So, the number 7. The mean speed of blah, 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 room temperature, da 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 da. So the probability that a randomly selected particle has a speed over 25,000, 2,500. And did I get the right answer for that? No. Yeah, I did. No, I didn't. Okay. So we have to do the formula.
Okay.
So it's just the way they did it. Okay, that was really easy.
Yeah.
The way they did it, they just plugged everything in. Because they
And
had all the information. And then you just plug that Z-score in.
Yeah.
Is that what they did next? Nope, that's not how they figured it out. Oh, okay, I see. I understand.
Okay. What does yours look like?
Do you get that one?
I understand how to do it, but my lines are different. Like.
You mean your red lines?
Yeah. Did you move your red lines,
I don't know if I got.
or did it automatically
Nope,
do
I
it
just
for you?
typed in the Z-score. Yeah, I just typed in the Z-score and it did it for me.
What I am doing wrong, because I type it in. Oh, just kidding. I found it. I'm missing one number. There we go. Okay, got it. 0.1216. Okay, so that's the probability. Okay, you ready for the next one? You understand that one?
Yep.
Okay. What is the probability that a randomly selected particle has a speed that is less than 250 miles per second?
Oh, go ahead.
So we
Sorry.
take the Z-score, which is the 1.1667, and
Because we just did the last one, this one's really easy because technically all we have to do is subtract the last answer from 1.
oh, okay. So we just highlight the other side instead?
Yeah, to highlight everything except the thing that was just highlighted, so the middle and the other side.
Oh, this app is going to come in. Oh my gosh, this is going to be a great app.
Yeah, I'm kind of loving it.
Ah, no kidding. Okay, so 0.8784.
Mm-hmm.
Oh, okay. Okay, what is the probability that a randomly selected particle has a speed that is less than or 1500.
Okay.
So we have to get a new z-score, don't we?
Yeah, so we're going to do 1500 times
Okay. Minus
minus
1800
1800.
divided by
Yeah.
600. Okay. Negative
So
0.05 or negative 0.
negative 0.5, yeah.
Yeah, type that little one in. Whoa. Okay, I got 0.3085.
That's what I got too. Is that what the answer key got?
Yes, that is what the answer key got. I'm going back and forth.
Oh, perfect.
Sweet. Good, good, good. Okay. What is the probability that a randomly selected particle has speed that is between 1500 and 2500? So we subtract something.
Yeah, I went ahead and looked at the answer key because I was confused. So what it did was it subtracted the 0.30 whatever we just got from what we had gotten for the probability the random selected particle had a speed that was less than 2500. So we subtract 0.3085 from 0.8784.
Okay, that makes sense.
Yeah, that makes sense to me.
That makes sense. Okay, so my calculator says 0.5699.
Yep, that's what I got too.
Okay, good. Okay. What is the third quartile of the speeds of hydrogen at room temperature?
So what I did to get that one was plugged in the 0.75 to get the 75th percentile and highlighted over there to get the z-score and then did the formula thing.
Okay, hold on, let me type that in. Okay, and it's asking for the z-score, right?
Mm-hmm.
Okay, so 0.67449. Is that what
Yep,
you?
what I got too.
Okay, good. All right.
And then we have to substitute in the
Oh, I skipped that one.
I did that wrong. I'm so horrible at like normal algebra, like honestly.
I'm terrible at math in general, so I understand.
So this should be fun.
Oh yeah, it's gonna be great. Okay, so
Yeah, so then we're supposed to plug that into the formula, and the answer we're supposed to get is 2204.4.
okay, and we're plugging that into the original formula.
Into the z equals x minus mean over
Oh, okay.
standard deviation, that formula.
Okay. Okay, so the answer key says 1800. Why is it the 1800 that we're using? Oh, just kidding. Just kidding, because that's the mean. I knew that.
Okay. The next ones aren't super duper difficult.
Okay, the next ones?
Yep, the plot.
Okay. So during your you determine whether are normally distributed or not. Record your answers for each graph. Oh, okay. Okay, so the first one, plot A, is, let me look at some other graphs. Okay, I'm going to say it's not.
Yeah, it's not because it's curved.
Okay. Plot B. Oh, we have to justify our answer because it's curved. Okay.
Yeah.
Plot B.
Also not, because it looks like an S.
Yeah. Okay, and plot C. Kinda, but I don't know.
I said no because it has curves. The answer key says, what does the answer key say? The answer key says yes, so I was wrong.
Okay.
So what the answer key says is that even though the points snake around the line, this happens with normal distributions. The data are classified as not normal if there's a consistent, distinct curve. But since it's not a consistent, distinct curve, then it's normal.
Okay. And plot D is normal. That's along the line.
Yep.
Plot E.
You said was not because it curves.
To the right.
Yeah. And the answer key actually agrees with me.
There we go. And plot F. Well, that's along the line, so plot F can be considered normal.
Yes. Okay, we did it. Are we ready to try this?
Yeah, let's do it.
Hopefully this goes well.
Oh, I know. Okay, starting.
I gotta get back there.
Okay, true. Are you ready?
Ready.
Okay, the total area under a density curve must equal wow, it's like
I'm
the one
pulling up
thing.
the textbook. It's 1, right? That's what I would think.
Yeah, I'm down. I don't
Yeah,
remember
I'm pulling
reading
up the
that.
textbook to check it real quick.
Okay.
Okay, normal distributions. Yep, the total area under the curve equals 1. One of the rules.
Okay, good. Okay. Excuse me. Okay. Under certain circumstances. Oh, go ahead.
Under certain circumstances, a density curve can drop below the x-axis, and that's false because I was just reading the textbook,
Yes.
and there's 2 rules, and one's that it has to equal 1, and the other one is that it always lies on or above the horizontal axis.
Sounds good. A normal density curve is symmetric. That's true. Do you agree?
I do agree.
Okay. Use the following image to answer 6 and 7. Which of the following elements of the figure represents the z-score in this image?
So C.
You got number 7.
Yeah. Which of the following elements of this figure represent the probability that the random variable z will be greater than 1?
B?
Oh. Yeah, I guess so.
Would
No,
it be?
I don't know. We don't. Wait, the probability can't be greater than 1.
Which of one?
No, that's the z-score. Probability can't be greater than 1 because you can't have 150% of a cake or something.
That's
right?
true. No. Which of the following elements of the figure represents? Wow, this is like a trick question.
Well,
Represents
A,
probability.
yeah, because A is showing us what equals 84%, and So what B is showing us is going to equal 16% of the graph, I guess. But yeah, because you can't have a higher probability than 1.
That makes sense. So none?
Yeah, that's what I would think.
Okay. According to the 68, 95, 99.7 rule, what proportion of the data from a bell-shaped distribution will be within 1 standard deviation of the mean?
68.
It wasn't 68 the first, though?
Yeah, because it's 68. This is 1 standard deviation, so 68%. 2 standard deviations is 95. I just did Math 108 last semester, and we had to go over that. That's the only reason I remember that.
We never went over this stuff in Math 108.
No.
And I took it like 2 semesters ago. Ugh.
I did the test out, so.
Nice.
Yeah, it was handy. Suppose random variable z has normal distributions. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places.
Okay.
Okay.
Okay, so what's the standard z-score then? That's what we need.
Okay, I don't use those random variables. You have some normal distribution. Yeah, because what I was just like looking at it doing, is I just moved the red bars onto 1 and -1. And then highlighted the number between that, and I got 68.685.
I wonder if he's gonna like, if we're like 1 decimal off, if we're gonna get it wrong.
I don't know. I don't know how like intense he is. Probably because this is a iLearn quiz, and iLearn is ridiculous.
You better believe it.
Okay, so 68.683.
Okay.
That's what I get at least.
683. I'm down. Because like I said, like you have to line it up exactly because like I have it on what it looks like -1 and 1, and I have 69.04. So
yeah, I just typed into the box.
Okay. Okay, suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2?
I got 0.955. I think he's trying to prove the 68, 95, 99.7 rule.
Sounds good.
Because that's
so 95.
Oh, I'm
95.
0.955.
Oh, 0.955. Okay, yeah. Okay, and what's between -3 and 3, which is the 99 point? Yeah, I think he's
0.997.
I'm sorry, I have something caught in my throat right now. Okay, look carefully at your answers to the last 3 questions. What do you observe? The values match the 6.
Yep.
So does he want it like the perfect like 0.68? Like, does it matter that we have the 0.683?
He wanted it to 3 decimal places, so.
Okay. Okay, next. Do you want it?
Oh, sure. The amount of protein that an individual must consume is different for each person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram of body weight with this formula. The population mean protein requirement for adults is 0.66 grams protein times kilograms to the -1 power times d to the -1 power, and the population standard deviation is 0.07 grams protein times kilograms to the -1. Use this information to answer questions 14 through 17.
So many numbers.
Yeah.
Okay, what proportion of the population have a protein requirement that is less than the 0.60 gram, all that, and then 3 decimals.
Okay.
Okay.
Well, we have to find the z-score. So we have the mean, so
Which is 0.66. Okay, so if I'm understanding this right, the kilogram to the -1, like, we really don't have to worry about that, right?
Yeah, no. We just have to deal with the numbers.
Okay. So, oh, 0.66 minus.
Did you get a z-score?
I'm entering the last number in right now.
Okay.
Okay, I got 0.857.
That's what I got too.
Okay, great.
Okay.
Okay.
And what part of this are we supposed to highlight? There's protein requirement that is less than, so
Which is less than?
yeah.
Okay. 0.8043?
Okay, I'm not sure where we highlight. That is less than 0.60 grams. So what I highlighted on the applet was the last blue section, the one most to the left, because it's less than the mean.
Oh, okay. So 0.1957, is that what you have?
Yeah, so 0.196 when we round up.
Okay, that makes sense.
Hopefully that's right. I'm so nervous with these that I'm gonna get everything wrong.
No, I understand.
Okay, so 14. What proportion of the population have a protein requirement that is more than 0.60? So then we just highlight everything else and not what we had just highlighted.
Okay. 0.1922?
That's not what I got.
Oh no. Okay, hold on. Oh gosh, come on. What did you get?
0.804.
Can you show me a picture of yours? Because that's not what I'm getting.
Yeah.
Oh, okay. I didn't have the other part highlighted. Gosh, it keeps moving. I keep accidentally clicking the little red lines, so it changes. Okay. What'd you get? Ugh.
0.804.
Okay, that's what I got too.
Okay. So what proportion of the population have a protein requirement that's less than 0.70? So back to the formula.
Wait, so what was our answer for 14?
0.804.
Okay, can we go over that? How did I skip something?
Okay.
So where did the 0.19 come into play?
What 0.19?
Or the 0.196. We did.
Oh, did I use the wrong z-score? So the z-score I had was 0.857 because it was the same z-score we had before.
Yes.
Okay.
And then the 0.196 is...
Oh, is the people that have a protein requirement that's less than 0.60. So then in 14...
okay. I typed in the z-score to 1. Whoa, okay.
Yeah, so 13 should be 0.196 and 14 should be 0.804.
Okay. I don't know what I was doing there, but I'm like, I'm one ahead. What's going on? Okay, we're good. Okay, so is less than 0.70, so we have to do that. Okay. we're on the same page again.
Okay, good. I'm glad.
So, okay, I got a z-score of 1.4.
Oh, okay. I think I might have done something wrong because that is not the z-score I got.
What'd you get?
0.571.
Okay, hold on. So we do.
70.
Oh,
Minus.
I did the wrong mean. My bad.
Oh, okay.
So 0.7. Oh, I always get it backwards. Does the mean come first?
No, the mean comes second.
Okay, that's what. Okay, no, I was doing that right then. I think I just had the wrong mean. Divided by. Okay, yeah, 0.057. I'm sorry.
0.057?
Or no, 0.57.
Okay, yeah, that's what I got too.
Ah, okay.
Make sure you give the next decimal place so it's 3 decimal places.
Yeah.
Oh yeah, we don't need that yet.
We don't need that yet. So.
Okay. And then.
Okay. So we put that little puppy into. Okay, and it says that is less than 0.7.
Right.
So we just do the last one highlighted, right?
And the middle one because 0.7 is greater than the mean.
Oh, I gotta pay attention to that. Okay, so 0.7163.
Yep.
Is that what you got?
Yep.
Okay, points. Okay.
Cool. And then we have to do a harder one.
Okay, to find the area between two values, you can subtract the area to the left of each of them. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. Give your answer as a decimal accurate to 3 decimal places.
Oh, so that's not that hard. Because if I understand right, what we do is subtract the proportion that's going to be less than 60 from the proportion that's going to be less than 70.
Yes.
So we do, okay, so 0.716 minus 0.196.
I believe so, because that's...
Okay. Except I don't get 3 decimal places. So I'm going to need to find 3 decimal.
No, wouldn't it be the 0.84 because it says between? Like, because
Yeah.
if you take the 1.96, that's including like 0.5, 0.4.
Right, which is why I was subtracting that from the from the stuff that's less than 0.7 because right now we have 0.7. The that 0.716 is 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, and we don't want the thing that's less than 0.6.
Okay, I see.
But I'm not getting 3 decimal places.
And then we minus this from the 0.84.
I don't think we need to use the 0.84.
Really?
Because we just have to subtract the area to the left of each of them. So.
Okay, that makes sense. I got 0.52.
Yeah, that's what I got too, but we need 3 decimal places.
Oh, that's weird.
The pain. So I'm going to come up here and use a more exact z-score, apparently. This means, okay, so 0.716 minus 0.196.
Subtract left.
Okay, 0.520. That's what I get when I find the third decimal place.
Sounds good to me.
Okay.
Oh. Okay, submitting. I'm always so scared.
How'd we do?
94 is what I got.
Okay, what did we get wrong? Oh, okay. I was wrong on the probability one.
Okay, that's fine.
Okay.
So, B.
So apparently you were right. Sorry.
No, it's
That
fine. No
didn't make
worries.
sense to me.
Okay,
Oh, I understand now. Okay, I was reading the question completely wrong.
okay.
I'm sorry.
Oh, no, no worries at all. I'm happy with an A, so it's fine.
Okay.
Okay, that makes sense though.
Yeah, I
Wow,
understand now.
we got all our numbers right. Yay.
Yay.
Okay, awesome.
So I was wondering, how late are you available?
What days are Tuesdays and
Like
Wednesdays?
Tuesdays?
Okay, it depends. Why?
Well, because I was just wondering if we could do at least next Tuesday's meeting, if we could do it at like 7:10 instead.
Yeah, that's fine.
Okay, cool.
Okay, so 7:10 for Tuesday.
Yeah, because there's something I want to do that goes from 5 to 7.
Yeah, no problem. Go ahead. That's
Okay.
fine. Um, yeah, what happened to the other person? Not Mariella, but the other one.
Dirk, I think that Dirk couldn't ever make our meetings.
Oh, okay. Okay.
Cool. Well, then I will see you on Tuesday.
Okay, sounds good. Thanks. Bye.
Welcome. Bye.